14.8 question number 1a. So we want to draw y equal 1.7 to the power x graph accurately. First of all, can you guess what kind of graph you are going to get? Because this is going to be positive. Yeah, of course positive, and it is greater than 1. Then we are expecting this kind of graph, and it should go 0 on compulsory, and since we need the starting point -4 and we need ending point +4, because the graph is draw -4 greater than x greater than 4. Then we need -4 value and 4 value exactly, because we need to finish the graph from there. So we'll consider some values x and y. -4, -3.85, and -2.21, and -1.8, 0, 1.2, 1.4, 1.2.4, 3.8, 3.5, and 4. So this is a disaster. We can work out it still, but when x equal -4, okay, that's fine. 1.7 -4. So this is going to be 1 over 1.7 to the power 4. Likewise, this one, 1 over 1.7, 3.85 hours. This one, 1.7, 2.21 hours. So this is a difficult table. Instead of taking these difficult values, I selected it for a purpose that because to show that we can still select those numbers. So this is going to be -3, -2, -1, 0, 1, 2, 3, 4. So this is going to be 1 to the power 7 -4, 1 to the power 7 -3, 1 to the power 7 -2, power 7 -1, 1 to the power 7, 0 is 1, and 1 to the power 1, it is 1.7. This is going to be 1.7 square, 1.7 cube, 1.74. This is 1 over 1.74, 1 over 1.73, 1 over 1.7 square, 1.1 over 7. This one going to be 0.12. This is 0.20, 0.3435. So this is -4, 0.12. This is -3, 0.23, -2, 0.35, -1, 0.5, 0 and 1, 1, 1.7, 2, 2.89, 3, 4.91, and 4, 8.35. That's a very important fact in here. So this is, I wrote, and so we have to mark this one, XY coordinates, which I'm not going to do. But one thing I want to emphasize, when there is a domain is given, the interval is given, we want to start from that interval, -2, and we need a ending point. If you draw up to 3, 4 is here, you up to 3, then your graph is not right, or you will get half a marks. Then you have to draw the curve, and I'm going to delete this one. -4 plus 4. So curve go like this. Don't overdraw beyond the 4. So -4 and 4. This is 0, 1, always go through. Now we done the graph, and use your graph to solve this one. 1.7 x to the power 4. Now, what is the meaning of this one? So we have y equal 1.7 x, and we have y equal 4. Now, how do we solve simultaneously? 1.7 x equal 4. Now, we have to draw this is one is trial and error. Other one method is apply logarithms. You will learn later. Another one is the graph. Trial and error, logarithm, and graph. So we are using graph method. So we need to draw y equal 4 line. So when you draw y equal 4 line like this, so this is y equal 4 line. So this is the point. So 4, then we need the x. So you will get value as, when you draw properly, rough figure 2.6. So you can draw properly with the coordinate I found out, and you can plot the graph and then merge these points and draw. I'll show you how to do trial and error with this one. So 1.7 x equal 4. Find 1.7 to the power 2. So you will get an answer from the calculator. Then find another one. So 2, and another one 4. 4. Then you will get 4. This has some number, another number. So you will try put in different figures. 2, 4. Then when it's come to here, 2.5, 2.56. This is 0. I'll draw differently. Okay, and this is 2 and 4. When x equal 4, 1.7 to the power 4. What is the value? We work out this value. This is 8.35. We'll get a different boundary, another one. We'll get 1.5. When x value is 1.5. 1.7, 1.5. 2.21. Now we need what? 4. Then you can increase in the numbers or decrease in this one. So then I will put when 2, so 1.72, 2.89. So then I will put 3. 1.73. That is 4.91. So the answer should be in between 2 and 3. We'll put 2.5. See the middle. So 2.5 is 2.5 is 3.76. Then I put 2.75. 1.7, 2.75. Let's see that value. So that is 4.75. 0. It means when you put 2.5, 1.7, 2.5 give 3.76, and 2.75 will give 1.7, 2.75. You will get 4.30. Then this answer should be in between 2.5 and 2.75. So then we want to try, okay, 2.6 next. What is 2.6? So 2.6, 3.97. 2.6, 3.97. So then we'll try 2.61. So that is 3.99. Then you can take 2.615, something like that. So that's how the trial and error with the work, but just for to give a sense, but don't use it because it is time consuming. We work out trial and error and the graphical method, and this one remaining the algebraical method. So 1.7x equal 4. I'll take the logarithm 4 side, log 10 to the power 1.7x equal log 10 to the power 4. So log this is like x log 10 to the power 1.6 equal 10 to the power 4, x equal log 10 to the power 4 divided by log to the power 10, 1.7. Approximate x equal 2.61. So this is the third method. You will learn the next this in this chapter. You will learn this one how to solve. But uh, yeah, that's all. Number 2, question number. So y equals 0.6 to the power uh, x. X value is -4 x. So this is the interval given. So I'm not going to draw this one. You have to take some values and you have to plot the graph. And what kind of graph you are expecting by looking at this? So we discussed three types. A minus 0 greater than A greater than or 1, and then A equal 1 and A greater than 1, or you can write like this, and this is going to be this one, this is here, and I can see this is 0.6, it has been less than 1, then I'm expecting this kind of graph. Now you may get this kind of. So this is my +4, this is -4. And the part B is we want to solve 0.6 x equal to. So we are going to use graphical method. This means y equals 0.6x and y equal to, when you try to solve this equation. So you are writing 0.6x equal to. It means if you see like this, then you need to recognize, okay, what is this one? Y equal 2 line. Then you have to draw y equal 2 line, y equal 2, and this y value is 2 here. Now you want to find the x value. So this is going 0, 1, x and 1. You get a approximate answer, x equal approximately -1.4. Question number 3, we already discussed. Sketch y equal 1 over x graph. whatever x value, the answer is 1. So for example, let's say x minus 3 minus 2 minus 1 0 1 2 3. So y equal 1 to the power minus 3 is 1 over 1 3 is 1 over 1 equal 1, and y equal 1 minus 2 is also 1. This is also 1 1 1 1. So I draw this one. This is a line, y equal 1 line. But you can write this is y equal 1 to the power x graph equal 1, always 1. Question number 4. There are two false. So y equal ax is go through 0 1 for all positive values. So this is number line. Real values mean this one. So when x equals 0, y equal a0, which is 1. Now this is not depend on a. We take any arbitrary number. So a can be anything, any number greater than this is a. Axis any number greater than e, greater than 0. Greater than 0, but a can't be 0. If a is 0, 0 to the power 0 is going to be 0. So then no exponential exists when a equal 0. So the statement is true. If I explain differently, okay, it can't be 0. Take any real positive number here. So this is 3.4, another one 4.7, and another one 10,000, and we are right. This is 3 point to the power 4x, y equal 4.7 to the power x, y equal 1000 to the power x. Likewise, we can get infinite number of numbers, and then apply x equals 0, which is 1. 4.7 to the power 0, 1. When x equals 0, 1000 to the power 0 is 1. For any to the power 0 is what? They all 1. Hence, all the positive real A. So how many positive real A's I selected so far? 3.4, 4.7, 1000. So likewise, you can select whole number line, infinite number of numbers. So they all going through this point 0, 1. And with our discussion, we said that all the exponential is going through 0, 1. So the same discussion I have to do again here. Then fx equal a to the power x. When a equal half, fx equal ax is always an increasing function for a greater than 0. Not this is false. A greater than 0 we discussed. Increasing function means this kind of function. Increasing function means this kind of function, or this one. Negative gradient, positive gradient. So No, it falls because we discuss only the function is increasing when 0 greater than a greater than 1, a equal 1, and 1 greater than a. Only function is increasing in 1 greater than a, because this is in here, although it is greater than 0, it's going to be not an increasing function. And here um, it is a decreasing function. This side curve, we draw this on the third other, so it is a decreasing function. That's why it is false. The fx is ax is an increasing function if a greater than 1. Fx is ax is a decreasing function if a less than 1 or 0 greater than a greater than less than 1. So you want to give a counter example. You want to show that when a equal 1/3, fx equal 1/3 x is a decreasing function. Is a decreasing function. Hence, the statement is not true. So the part says the graph of AIX where A is a positive real number never crosses the x-axis. So by theory you should know that this graph never crosses the x-axis, either this side if you draw like this, and this graph will touch at x-axis at infinity. When it's come to infinity, it will touch. Likewise, this graph, when it's come to infinity, it will touch. That's the argument. Only touch, not cross, only touch at the infinity. In general, you can tell that it's never crosses. Question number 5. Fx equal 3 to the power x. So A, we want to draw y equal fx. So this is normal again. This is going 0, 1. Y equal 3 to the power x. Now B, y equal to fx. Now chapter number 4. Now this is a stretch, vertical stretch. Now this is a vertical stretch with scalar factor 2. So when y equal 2 times 3 to the power x, when x equals 0, y equal 2 times 3, 0. So 2 times 3, 0 is 1. So 2. So graph is going to 0, 2 now. So this point is now 0, 2. This is y equal 2 times 3 to the power x, or y equal to fx. When you consider this height 3x, then the same x value, this height is one more time, 2 times. Now, part C, fx minus 4. We have the graph y equal, this is 3x, y equal 3x equal fx. Now, we want to bring this one by 4 down, 4 units. So, this point 1 unit, 2 unit, 3 unit, 4 unit. So basically, then this one x-axis 1 unit, like this. So the graph is going like this. The same graph, it is below the, for this point is 0 minus 3. You want to bring 4 units down the same graph. Then 1 point become minus 3. And the asymptotic, horizontal asymptotic y equals 0, which is x-axis, now is at where? Y equal minus 4. So the graph is a translation by vector 0 minus 4. When x equals 0, y equal 3x minus 4, which is 3 0 minus 4, 1 minus 4, minus 3, 0 minus 3. But by observation also you can show that if I draw here, so this is the graph. So I want to bring 1, 1, 2, 3, and 4. Parallel to this graph, every point. This is 0 minus 3. And this is y equal minus 4 line. Now part D, y equal f half x. So if x equal 3x, f half x means 3 half x. This is 3 half times x. In other way, square root 3x. But so you can think about this is horizontal edge stretch. Stretch of scalar factor 2. So you will get this kind of graph. This is when x equals 0. If x equals 3 half x, 3 half times 0 is 3 0 is 1. Still going to 3 0, but stretch 2 times. So this is going to be y equal 3 half x or y or f half x. So this is A graph, then this is B graph, then this is C graph, and this is D graph. Y equal K A 6 K A X. When x equal 1, y equals 6. So we'll substitute this detail. So 6 equal KE1. Then when x equal 4, y equal 48. So 48 is KA2. So this is 1 and this is 2. So 2 divided by 1. 48 over 6 equal Ka square over Ka. So 8 equal 8. K to cancel out. A square over A. So A value is 8. I think x equal 4. So then this is not A square, A4. So then this is going to be A4 over A. So this is KA1. K to K cancel out. This is A4 over A1. A4 minus 1. A3. So A3 equal 8. Then 2 to the power 3 is A to the power 3. So then only possibility is when the power is equal 2 equal A. So A equal 2. Now we want to find the K from 1. 6 equal K A. But we know now A is 2. K times 2. So 6 equal 2K divided by 2 both sides. So K equal 3. Question number 7. Y equal PQ X. P times Q times X. And this is minus 3, 150. And this graph is going to 0.048. Part A, by drawing a sketch or otherwise explain why 0 Q value has to be in the 0, right? Okay. We can do a sketch. So we know x value when it is minus 350, when it is 2 somewhere here. So we can see the direction, then it has to be in this direction. And we can find this one if x, when x equals 0, y equal pq0, p times q0 is 1, p. So this is going to 0, p. Right. So then the argument, if it is in this direction, then q has to be in 0, q 1, in between 0 and 1. Or you can come different argument. You can get different argument. When x equal minus 3, y equal 150. This one. So we'll apply when y equal, this has to be 150, but p, what is q, minus 3. Q, its value is minus 3. Then this has to be 1 over q to the power 3. So this is p times, and this is p times 1 over q, 1 over 3, 3q, because 1 to the cube also cube. So this is 1 over q to the power 3. Basically, this q minus 3 means 1 over q to the power 3. So this is equal y equal a b a x form. And we can see that this is a fraction. 1 over q is a fraction. Actually, let me take a different easy approach. We can show this one by taking a decreasing function. So find dy by dx, or the gradient m, y1 minus y2, that is 150 minus 0.4048, and minus 3 minus 2, and this value is less than 0, hence this is a gradient is negative. Gradient is negative, hence function is decreasing, and the only possibility is when 0 greater than q greater than 1. In exponential, only q is fraction, or in between that we get the decreasing function. Now we need to find the values. We'll apply when you consider this one. 150 equal p times q times minus 3, and when we consider this one, 0.048 equal p times q times 2. I'll take this is 1 and this is 2. I'll divide 2 divide by 1, because I can see q, this is negative, I can make positive, so 150, sorry, 0.048 pq square, this one, divide by 150 pq cube. So this is cancelled out. So this is going to be the 0.00032 equal, this is q square times q minus 3. Q minus 3, now this is q square, this minus 3 become q3. So this is going to be 2 plus 3, 5. So q5 equals 0.00032. 1, 2, 3, 4, 5. So we know 2 to the power of 5 is 32. We can think about something like that. Q5 equal 0.2 to the power 5. hence q equal 0.2 or 2 over 10, which is 1 over 5. Now, which one is the easy one? We'll stay with this one. From 1, 150 equal P over Q3. I bring it down, then P equal 150 times Q3. So 150 times 0.2 to the power 3. So this is going to be 8 and 1.008. This is going to be 1.2.